Okay, today we are going to discuss about finite element software tool because in our industry, the most of the analysis in nowadays the most of the analysis done using the software packages. So no, actually the very rarely we can find the manual calculations, the CAD design, and also the analysis done using the finite element softwares. Among these software, the ANSYS workbench is a very powerful tool widely used in industry. So I'm going to give introduction to this ANSYS workbench software today. The ANSYS workbench it is actually developed in 1970 by John Swanson. It is originally developed to analyze the stresses in nuclear reactors. Say originally developed to stress analysis actually. So then nowadays it various kind of analysis can done using the ANSYS software. The various fluid flow analysis, thermal analysis, heat transfer analysis, the stress analysis, vibration analysis, combustion analysis. The various type of analysis can done using the ANSYS software, ANSYS workbench software. The ANSYS workbench giving the full graphical interface to develop your project. That is the one of the advantage in ANSYS workbench. It gives a full graphical interface, user-friendly graphical interface to develop your project and to get the result. So then what we need, we have to give input of our data, then it automatically generate. And also it having the very powerful mesh generation tool, the robust and powerful mesh generation tool know the minimum errors. It's a very powerful tool in mesh generation. Then it also parametric design also possible with the ANSYS workbench software. Parametric mean and also parametric optimization also possible. That means if you are designing a certain component, we can give a certain dimension. We can uh, keep it as a parameter. So then by after doing optimization through the finite element, we can modify this parameter. Then we can get this parameter to a optimum position against whatever constraint limit. So then this parametric optimizations are possible with ANSYS workbench. One of the major advantage I'm looking in this ANSYS workbench software. So the practice in this one of finite element tool is very important when you're going to work on industry. I am suggesting to, as a beginner, ANSYS workbench software I am recommending to you. Then when you're going to work on industry, you may find the different software, specific type software for. There's a lot of software in the around the industry. The 400 softwares are available in industries, around the 400, yeah, the available in industry for the finite element analysis. As the general purpose software tool, finite element tool, ANSYS workbench give good solutions. When you're going to work on industry, you will definitely find some specific type softwares for certain tasks. So what the knowledge gain under this subject is more helpful to familiar with those software in future. Okay, let's move to this. Today I'm going to give the introduction and everything about this ANSYS workbench. So then we can go to then we have move to complex analysis. So okay, this is the opening window of ANSYS workbench software. It is open in a project tab. You can see the project tab. Then this is the top. You can see the menu bar. Here it is called the tool menu bar. Then this is called the toolbox area. Then this is called the project schematic area. That means your project you have to create on this area. Then this is the property box area is open. That means property what you are doing in here, the project schematic area, the selected item property shown in this project property schematic area. Okay, then again you can see the bottom, you can see the status bar. Once you click on this progress, it shows the progress of the calculation also. Okay, once you click on the messages, error messages and the warning messages and the informations are shown in this status bar menu in the right hand side corner, you can see. Okay, then the project schematic area, this is the area you have to design your project. Then in a toolbox, let's look at this toolbox first. Okay, first let's look at this toolbox area, having the 5 collapsible menus: analysis system, component system, custom system, design exploration, and external connection system. Once you click on this plus sign, it will expand and show what are the content. Here you can see. Okay, first let's look at the analysis system. That means analysis system, it's a predefined tool. That means predefined set of tool for certain analysis gathered in a one shell, one system called the analysis system. For example, if you take a steady state thermal analysis, then you can see the steady state thermal analysis. The required to do this steady state thermal analysis, the required tools are gathered into one system. The engineering data mean the material property of the material property we have to define. The geometry we can import external geometry, or we can design a new geometry. There's inbuilt 3D modeling tool also. Then the model, the finite element model, we have to define the finite element model in this here. Then the setup, so what are the boundary conditions we have to give in setup part. The solution, what are the solution we need at last. Then the result showing, the graphically how the result is shown this in this shell. You can see the 1, 2, 3, 4, 5, 6 shells that we have to feed data for these shells. Then we can get the result output. Then this analysis system also, we can give the each system they are assigning default letters, but we can give the custom name for our system. Test 1, I'm giving the test 1, like that. You can give the custom name also. Okay, then you can see the various analysis systems are there because this tool can use to analyze the different analysis can do. The fluid flow analysis, thermal analysis, the vibration analysis, the different type of analysis. According to the analysis you are doing, you should be able to select. You should know how to correct analysis system you have to select. Okay, that is important. Okay, then again you can see the component system. In a component system, you can see the component wise one or few shells gathered in this component system. For example, if you get the geometry here, only one shell is there. The geometry you can define using this component system. Then this defined geometry you can share with the other systems also. For example, I will show you. This is the geometry shell. Then if we are doing thermal analysis and also the static structural analysis for both on a single geometry, we can share this data. We can share this data in both the system. That means this geometry is shared by both systems for analysis. Okay, then in that way you can develop very complex and complex analysis you can design in that way. No need to define the geometry again and again. And also same as the finite element model also. Okay, finite element, I will show that one also. You are defining a finite element model for certain geometry, then you can share that model with the other analysis system also. Okay, you can see the geometry. Let's take the mesh component I am taking. You can see the mesh component system, having the two shells. So I'm going to share this geometry with this component system. Then we can define the mesh. Okay, so that means let's take the fluent also. Then the fluent, then we can link this data. That means the mesh, the finite element model generated here, we can transfer to for the setup in a fluent analysis. This is how we are linking this link can by linking the component system. This is how we are developing our project. Okay, then this is the component system and the analysis system. In that way you can use the component system most of the when doing a complex analysis. No need to define the finite element model, no need to create the geometry again and again. So then another design, you can see the custom system. It is customized to do a certain specific thing. Let's see. Then you can see the thermal stress response spectrum, random vibration, the pre-stress model. These are custom systems. For example, if we double click on this, it will appear on this window. You can see this is the thermal stress system. That means you can see this data is shared. The engineering data is shared, geometry is shared, and the model also shared. Then you can see this is transferring. The data is transferring. This dot sign is saying the transferring. This square sign is saying the sharing, data sharing. That means this solution of this steady state thermal analysis is transferred into a setup shell of the static structure. That means the free thermal stress mean the stress causes due to the thermal expansion. So, and this we are doing first this analysis to find what is the thermal expansion. So then if we know this thermal expansion values, we can predict the stress developed due to this expansion. No, yeah, that is the thing in the custom system also. Okay, then there's a various type of the systems also there. Then again you can see the pre-stress model. The later we can further discuss how to use this system also. Then next one, the important thing is the design exploration. Design exploration mean you can explore your design. You can explore your design mean you can see the tool in there. The direct optimization, parameter correlation, the response surface optimization, generating a response surface. That mean various type of exploration about your design you can do using this design exploration. That means, for example, response surface optimization can use to optimize certain parameter against a certain constraint limits. Okay, multivariable optimization also possible with the this workbench software. That is one of the powerful one of the main advantage in working with the ANSYS workbench software. So actually we are doing this response surface optimization in this practical session also. Then and lastly you can see the external connection system. That means you can link external application. You can link the external application with the your project. This external connection, this component act as a proxy for that application. Okay, later we can discuss about this one. Only this newer version, this included this newly included component external connection system. Okay, then now let's look at let's see how to do certain analysis using the ANSYS workbench software. I gave introduction to this menu bars and opening window of the ANSYS workbench. Then now let's see how to design how to do a certain analysis using the ANSYS workbench. Okay, now let's see how to do a small analysis using this ANSYS workbench software. So then later we can go for the complex analysis. Let's say starting with the very simple analysis. Okay, I'm going to do the static structural analysis. Static structural. Then we are in the project tab. Then when doing this analysis, you have to view data from the top to bottom. Then we are getting the final, we are getting the visual. So then first I'm going to give the name for this analysis. Actually I'm going to do this analysis. You can see the metal aluminum alloy plate. This take is a bracket for certain component, system component. Then the thickness of this plate is 2 centimeter. Then here the height is 8 centimeter. Then the 15 centimeter in length. Then there's a hole, the 4 centimeter in diameter hole is there. Then this end is fixed support, welded or any fixed support. At this end you can see the free end, the 10 kilonewton force is applied. Okay. Then we are going to analyze the stress developed in this system and also the displacement, how under this force we are going to analyze. Okay, then let's see. Then first you have to define the engineering data. Then once you double click on this engineering data, it will open in a separate tab. Here you can, if you want to go to the previous tab, you click on this project tab. Here you can see we are in the separate tab. Okay, project tab, engineering data tab. Then here you can see as the default material, the structural steel is selected. You can see. Okay, then today I am going to give the one of the method. In this lecture I am going to explain one of the method to define the engineering material. There's a several method to define the material. You can define the user input material also. You can duplicate the material. You can edit the material also. So one of the method I am going to explain in today. You can import the required material data from the library, engineering data source. Once you click on this, it will open. Then you can see these material properties are there. Okay. Then here you can see the several windows are open simultaneously. Yeah. Then you can see the general material, nonlinear material, the thermal material, fluid materials, different type of materials are available. So I'll click once you click this general material, the general materials are shown in this window. Then you can see the air, aluminum, concrete, copper alloy, grey cast iron, the various type of materials are shown in here. Okay. Then what I'm going to do is I'm going to add the aluminum alloy to our project. If you click on this plus sign, it will automatically add it to your project. Okay, that aluminum alloy data also shown in this the bottom window. Then here you can see the bottom window, the properties of the aluminum alloy is shown. The tensile yield strength, the compressive strength, tensile ultimate strength, those are shown in this window. Then Poisson ratio, the 0.333, the Young's modulus also shown. Then the properties, some graphical representation also given, how the Young's modulus in this window. You can see the Young's modulus, how it vary with the temperature is shown. Then okay, I have added this aluminum alloy to our project. Okay, then let's move to the, then you can close this window also. Oh, I'm going to close this one. Then for our project, the aluminum alloy data is added. For the project it is added. There's another situation we have to add. We have to assign that material. Here you can see the aluminum alloy and structure both are there. For the project it is added. For the material, for the geometry, we have to assign the aluminum alloy later. So then once you click on this geometry, if you right click, you can import external CAD geometry or saved CAD geometry also, or you can create the new geometry using this new geometry icon. Okay, so I'm going to create the new geometry. If you double click, it also open in a new tab. Okay, you can see in this time the geometry is open in a separate window. Okay, design modeler open in a separate window. Here you can see the design modeler. Okay, the same as in normal CAD design software, there's a coordinate systems, XYZ coordinate system also there. Then we can gradually familiar with this design modeler. Then here we can the sketching toolbar and the modeling toolbar also there. Then the design feature add in design tree also there. So this is the one we are going to design model. This is the component we are going to model. Okay, let's see how to model using this design modeler. So first, same as in other CAD geometry software, you have to assign a plane. So I'm going to select the XY plane, then make it to normal to the view. Okay, then go to the units. Then I'm going to select the centimeters, because the dimensions are given in centimeters. Then it is more easy to model with the centimeters. Okay, then the sketching rectangle. Okay, draw this rectangle. So the first I'm going to give the dimensions. Vertical height, vertical dimension we have to give separately. Here you can see that this dimension, the given dimension is 8 centimeter in height. Okay, then what is the horizontal dimension? Width is 15. Okay, is 15. At the center there's a hole, then a 4 centimeter hole is there. So I'm going to draw that hole also. Draw circle. The circle diameter is 4 centimeter. 4 centimeter hole. Then we have to center that hole by giving the dimensions. I'm going to center that one. It is 15 the 7.5 the vertical, that is 4 centimeter. Now it is centered. Okay, then we can extrude, revolve, sweep, loft. These are commonly available 3D modeling method in other softwares also. Then I'm going to extrude. I'm going to extrude this one. So then normal to this plane direction, the dimension is 2 centimeters. Okay, direction is 2 centimeters. Okay, click on this generate button. You can see our model has created. Our model has created. You can see our model has created. Solid. Then its data is given, the surface area, the faces, edges, and the volume also given. Add material process we have done. Then this data has given. Okay. Then now we have create the geometry. You can close this window also, because we have already create the window, create the geometry also. Okay, then you can see the tick mark is appear. The engineering data has defined, the geometry also defined, that's why this tick mark is there. Then the refreshing is needed. That means this geometry, the model, finite model has not created, that's why its refreshing mark is there. So okay, let's move to the finite model. Here you can see it is open in a separate window as same as geometry modeler. You can see the feature adding design tree here, and this is the model. Then for the geometry, first thing you have to do is you have to assign the material. Go to highlight the solid and assign the material. Then static structural. You have select you can see the aluminium alloy. You can add the aluminium alloy to a project. Okay. Then the properties, again you can see the properties of this centroid and mass, everything are there. Then okay, let's move to the mesh. Then there's various methods. There are a lot of various methods are available for mesh generation and optimization, but in this level, in first tutorial level, I'm going to create the very simply mesh, very simple mesh. So then if I right click on this mesh, you can generate the mesh, generate mesh. Then here you can see the mesh has generated. Okay, here you can see the mesh has generated. Okay. Then one technique I will explain to optimize the mesh today, the sizing. sizing. Then you can see the relevance center and coarse mesh, the medium mesh. What happen if you select the medium mesh, if you select the medium mesh, then update, you can see the mesh size is smaller to a previous one. That means we are getting with higher accuracy finite element solution. The fine solution, update, okay, you can see the further it is optimized. So you can go to this statics. You can see the number of nodes, number of elements, the 15,876 elements are there. The details are given in this static part. Then in this level I am going to explain only this one, using the relevance center, how we can modify the mesh. Then later we can discuss advanced mesh optimization method later on. Okay. Then static structural. Then as the solution what we need, we have to define. Okay. As the solution finite element model, first then we have to define the loading condition, the boundary conditions. So here this end is fixed support, the support condition fixed support. Okay. Then this one, the downward force is acting on this the load force. The vector, I am selecting the vector by component. You can see in a y direction the component we have to give the y direction. In newtons there, the minus, because it is in a downward direction. Okay. Then x component and z components are 0. You can see it is shown in this window also, the assign force also shown. Okay. Then here we have assigned the loading condition and the boundary condition as the solution what we need. Okay. Here we have assigned the force and the fixed support. Then solution we need. Next we have to give what is the solution we need. Then I'm going to calculate the stress. I'm going to calculate the normal stress in x direction. So how this is the bending stress, that means due to this deformation, how the stress develop in x direction. Yeah, maximum principal stress. Okay, let's take the stress as maximum principal stress, because it's mostly closer to the two-dimensional structure. So I'm going to take the maximum principal stress. So then I'm going to interesting also about the directional deformation, of the body. I'm interesting of this body, the entire body deformation in y direction. Okay, the directional deformation of this selected body, how this is deformed in downward direction, what is the amount of downward direction deformation I am interesting. So then this is as the solution we need these two things. Then okay, then Let's click on this solve, generate the solution. It takes a few minutes to generate the solution. If the number of the elements are higher, it takes a longer time to generate the solution, but with a higher number of here we are having the solution. So first let's look at the principal stress. You can see how the principal stress is vary on this then here you can see it is in Pascal, unit Pascal. You can see the maximum somewhere in here, then the minimum somewhere in here. Okay, you can this probe to measure this any of this position stress. You can calculate the maximum is this is the maximum 2.09995 into 10 to the power of 8 Pascal. The minus sign indicating the it is that area is subjected to a compressive stress. Here the positive sign plus sign is saying it is subjected to a tensile stress. Actually this structure is acting in downward direction. The upper layer is subjected to a tensile stress, the bottom layer is subjected to a compressive stress. This is how the stresses are vary in this maximum principal stress is vary in this structure. Then the directional deformation, you can see the directional deformation, how the deformations occur. The zero, you can see the then you can see the directional deformation. The maximum somewhere in here, the maximum mean it is the deformation is 0. Then all others are negative values because the y-axis in this direction. Then the minimum somewhere in here. Okay, the minimum somewhere in here, that means there is a maximum deviation happening on this point. That deviation in meters, you can see this is the maximum deviation of this component from the original position. Okay, this is how we are calculating the this is how we are doing the analysis. And then you can see the this deformation. You can preview like this. The animation shows how this structure deform and how the stress are distributed with the time. You can save it as a movie clip also. Okay, so then again, if you want to add some analysis, that means if you after this, if you are interested to add the more and more solution, the stress, let's take the equivalent stress you want. Again you can okay, so then it will generate the equivalent stress also. So here you can see the equivalent stress, how it is distributed in the structure, equivalent stress. Okay, the later in a upcoming lecture, upcoming tutorials, I will explain how to assign the material, how to define the new material, and also mesh optimization method, and how to do the complex analysis. We can discuss on upcoming lectures. Okay, thank you. Let's continue next day class.